data collection and sampling technique. Like we mentioned this earlier, so let's go over it a little more in detail. Samples should be random and representative to create unbiased pictures. Unbiased sampling technique. To obtain samples that are unbiased, give each subject in the population an equal likely chance of being selected. Statisticians routinely use one or more of the following methods. Random sampling. Use chance method. All members of the population are equally likely to be chosen. For example, you draw a name from a hat. You have a classroom consisting of 36 students seated in the 6 different rows. With 6 students in each row, the instructor rolls a dice to determine a row, then roll the dice again to select a particular student in the row. This process is repeated until a sample of 6 students is obtained. So this is also random. If systematic, a number of members choose the case 1. For example, teacher assign number to each child in her classroom, having them count off number from 1 to 10, then select every 8th student. So that is a system, right? Another way to do that is, say your classroom consists 36 students sitting in 6 different rows. With 6 students in each row, each student in the row assign number 1 to 6. She roll a dice and get a 4. So every 4th student is been selected. So the sample that she collect is systematic. Stratify. Divide population into at least 2 groups called strata, then randomly sample within each group. So for example, take each class on campus, the stratum, then choose 2 students from each group. Okay? So say, again with 36 students, a classroom consists 36 students sitting in each 6 different rows. With 6 students in each row is designed as a strata. So you roll a dice to randomly select 1 person from each group. So this is stratify. Cluster. It's slightly different from stratify. Members of the population are grouped, then entire group are chosen. So take each class on campus, then pull all students in classroom selected class. A classroom consists 36 students seated in 6 different rows. With 6 students in each row is designated as a group. Then the teacher rolls a die to randomly select the whole group. So say for example, I have 6 groups. Group 1 is in row 1, 1, 2, 3, 4, 5, 6. In row 2, 2, 2, 3, 4, 5, 6. In row 3, 3, 2, 3, 4, 5, 6. So on and so forth. Then I roll a die, say I roll number 3. Then this entire group being chosen. Okay. Other sampling technique, convenient, use the result obtained from surveys. For example, go to mall to ask questions, or like in the previous example, stand in front of the library to ask students who in organic chemistry for the cost of books, right? Or go to the gym to ask the senior citizen how much they pay on books. So that is convenient example, convenient sampling based on what is it that you want to answer, based on the question that you want to answer. You can have volunteer sample or self-select sample, decide for themselves whether or not to be included in sample. Okay. When we collect this using convenient sampling, usually this result are very biased and not representative of the entire population. So let's take a look at another example. I want to do a survey of people in the Bay Area. I want to know whether they will vote for Democratic or Republican candidate in the next presidential election. I random select 100 people, 100 number from each of the 8 area codes in the area. What is my sampling method? Is it systematic, stratify, or cluster? So this would be stratified, right? So I have 8 different area code, and then I call randomly in each of those area code. What is the level of my measurement, nominal or ordinal, interval, or ratio? Before I answer that question, let's talk about level of measurement. So what is it is nominal? Nominal when the classified data into mutually exclusive, non-overlapping category in which no order or ranking can be imposed on the data. So this is category. And none overlap. And no order. Ordinal. Ordinal classify data into category that can be ranked. However, precise difference between the category do not exist. So for example, the number of the pizza order by small, medium, or large, right? Category, and it can be ranked small, large, or medium. Interval. You can rank the data. Precisely different between unit measure do exist. However, there's no meaningful zero. Okay, so say for example, the tree grow 10 feet compared for today, this year to last year. So there's no meaningful zero. The ratio. It proposes all characteristics of interval measurement. There exists a natural zero. In addition, two ratios exist when the same variable is measured on two different members of population. So it can be ranked. There's natural zero. And you can talk about proportion between two variables. So here, I want to do a survey of people in the Bay Area. I want to know whether they will vote for the Democratic or Republican candidate. In the next presidential election, I randomly select 100 phone numbers from each of the 8 area codes in the area. So, and then I'll take sample. The level of this measurement is nominal. Yeah. Because you can call the people can say whether they vote for Democrats or Republican, right? So here you have two different things. You have Democrats or Republican, there's no overlap, there's no independent, no ordering to political party. When we take sample, there's Sample and error. Sample and error is the difference between the result obtained from a sample as the result obtained from the population from which the sample was selected. For example, a sample showed that 45% of Las Positas College students enrolled in the fall 2018 semester are new Las Positas College students. After checking with admission and record, the actual value turned out to be 42. So the sample and error is 3%. So there is an error. Non-sampling error occurred when the data is obtained by erroneously or sample is biased, non-representative. So for example, standing out front of the library to collect the sample on how much people pay for textbook in the previous example. So that is a bias. And the data cannot be used as representative data for the entire population. So for example here, a radar gun used to clock baseball throw was calibrated incorrectly, or perhaps the researchers flipped. So you could have something reading as a wrong number. Okay. Experimental and design. So the type of sampling data, you can have observational study. The researcher merely observe what is happening or what happened in the past and trying to draw a conclusion based on observation. There's advantage and disadvantage to this. The advantage, usually occurs in natural setting. It can be done in the situation where it would be unethical or downright dangerous to conduct an experiment. It can be done using variables that cannot be manipulated by the researcher, such as drug user versus non-drug user and left hand versus right hand. Disadvantage. A definite cause and effect situation cannot be shown since other factors may have effect on the result. So say for example, a drug user, what kind of environmental that they grow up in, what kind of housing that they are in. So there's many different effects that come with it, many things that cause it, right? It can be expensive and time consuming because you have to pay someone to observe that. And in order to make the data meaningful, you have to observe for a long time. The result could be subject to incurable inaccuracies of those who collect the data. Well, you could miscollect data. You could make a mistake, copying it out, then entering the wrong number into the computer. Anything possible. A confounding variable or looking variable is one that affects the variable included in the study, but it's not included in the study. Say, for example, like I said earlier, people who use drug and people who not use drug. What kind of family that they grown up in? What kind of job do they hold? It all depends, right? So you have the looking variable that is not included in the study, but it greatly affects the result. We have different experiments. Okay. Researchers can manipulate one variable and try to determine how the manipulation influences other variable. You have independent variable. In an experimental study, is one that is being manipulated by the researcher. Independent variable, also called an explanatory variable. The resultant variable is called a dependent variable or the outcome. The typical treatment group is given instruction on try a rug, for example, and a control group given no special instruction or placebo. Advantage. A researcher can decide how to select subject and how to assign them to a certain group, as well as control or manipulate the independent variable. The disadvantages can occur in unnatural setting, like in the lab or in the classroom. Right? The Hawthorne effect. The subject who know they are participating in an experimental study and change their behavior in a way that can affect the result of the study. Yeah. co-founding variable influence the dependent outcome variable, but were not separate from the independent variable. Okay. Let's say, for example, determine whether an observational study or an experimental study is used. A survey was taken to see how many times per week a person visits a fast food restaurant. Okay, so right here, we can see that we can just sit in front of a fast food restaurant, right? And we just observe how many times this person go to a fast food restaurant. So this is observe. A study was conducted to see if the people who have pet walk a greater distance than the people do not have pet. Well, again, we can just observe, right? Three groups of gamblers were randomly selected. The first group was given 25 in casino money. The second group was given $25 coupon for food. The third was given nothing after the trip to the casino. Each group was surveyed and asked their opinion about their casino experience. So this is more than experimental. Okay. Now, with all the sampling technique, with all different experiments, there can be a misleading conclusion. We can have subject sample, or we consider where the data come from. You can have faulty survey question. The way questions are based can often influence how they answer. We can have a misleading conclusion. You can have detached statistics, a claim in which no comparison is made. Say, for example, our brand of soda have 10% fewer calories, fewer than what, right? So what is it that you compare to? You can have implied connection. For example, be on lookout for words like may in some people and may help. Well, the claimant that may or may not exist here. Precise number and percent. A number that does not appear rounded does not make number exact. Say, for example, Sarah sold 100% more cookie this year. Well, let's say last year Sarah sold 1 box of cookie. This year Sarah sold 2 boxes. So she make 100% more. But the number look there's a lot more than this actually is. She sold 2 boxes of cookie this year compared to 1 box last year, right? Statistical thinking. When you look at a statistic problem, you need to ask yourself, what does the data mean? What is the study of this? What is the goal of this study? Where's this data come from? Is it reliable? What method is data being collected? Okay. You can have graph. You can analyze the data. Is there any outlier? Is there any missed data? Apply statistical method. And then you can conclude, is it significant? Do we have any result? Right? So there's many things that come when you do statistics. You need to look at data, making sure your data is right. Now that you have all that data, what can you do with those data to get a meaningful answer to the question that you proposed originally?